Hello students and good morning. So now I am doing class for class 10. So today's topic is the same topic that we were doing in the last online class, that is concept of measurement of angles from trigonometry. So today we will continue this chapter. So let us work out exercise 20, page number 276 from the book Ganit Prakash for class 10 by West Bengal Board of Secondary Education. So let's do this question number 5. So in the last online class we finished question number 4. Let's do this question number 5 now. So in the question it is given that the measure of one angle of a triangle is 65 degree and the other angle is pi by 12. So in the question it is given that there is a triangle and the measure of one angle of a triangle is 65 degree. It is given in terms of sexagesimal system, and the second angle or the other angle is pi by 12, that is in terms of circular measure, that is in terms of radian, pi by 12. So let us write the sexagesimal value and the circular value, the third angle. You have to find out the sexagesimal value and the circular value of the third angle. And in a triangle, you know that the sum of the three angles of a triangle is 180 degree in terms of sexagesimal system and pi radian in terms of circular measure. So let's do this question now. So let's do the solution now. Now you know that the sum of the three angles of a triangle is 180 degree. Okay. So one angle of a triangle is, let us write here, one angle of a triangle. One angle of a triangle is equal to, this is your 65 degree. What is the other angle or the second angle? So other angle or second angle is equal to, this is in terms of radian, that is pi by 12. So let us convert it into sexagesimal system, and you know that pi radian is equal to 180 degree, you know that, isn't it? 180 degree divided by 12. So you can cancel it. 12 ones are 12. What is 18 minus 12? 6, and it is 60. 12 fives are 60, so it is 15 degree. So we have found out the other angle or the second angle in terms of sexagesimal system, that is your 15 degree. So you have to find out the third angle in terms of both sexagesimal value and in terms of circular value. So now let us write down here, let the third angle be theta. What is the third angle? We have assumed that is theta. And you know that the sum of the three angles of a triangle is 180 degree in terms of sexagesimal system. So therefore, what is one angle? It is 65 degree. What is the second angle? It is 15 degree plus third angle is theta, which is equal to 180 degree. And you know that the sum of the three angles of a triangle is 180 degree. Okay. So 65 plus 15, 5 plus 5 is 10, 0, 1, 7 plus 1 is 8. 80 degree plus theta is equal to, this is your 180 degree, or theta is equal to 180 degree minus 80 degree. That is, theta is equal to, this is your 100 degree. Therefore, third angle in sexagesimal value is 100 degree. That is the answer. Therefore, let us write down the answer. Third angle in sexagesimal value. Sexagesimal value, that means in terms of degrees, which is equal to, this is 100 degree. Okay. This is your 100 degree. So this is the answer. So I think you have understood it. So now you have to convert it into circular value or in terms of circular measure. So which is equal to now 100 degree. It should be multiplied by pi radian. So you don't have to write degree in this case. Okay. So now since this degree is converted into radians, don't write degree. Since this degree is converted into radians, so don't write degree. So just write only 100 into pi by 180. Is that clear? So here 0, 0 gets cancels. So you can cancel it by 2. That is 2 5s are 10, 2 9s are 18. Which is equal to, what is the answer? Pi radian divided by 9. So this is in terms of circular value. Therefore third angle in circular value or in circular measure is equal to, what is the answer? It is 5 pi radian divided by 9. So this is the final answer. So I think you have understood it. Okay, so you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 6. So the question number 6 is, the sum of two angles is 135 degree and the difference is pi by 12. So here the sum of the two angles is given as 135 degree, that is in sexagesimal system, and the difference of the two angles is pi by 12, that is in terms of circular measure. So let us determine the sexagesimal value and the circular value of the two angles. So you have to find out those two angles whose sum is 135 degree and the difference is pi by 12, and you have to find out those two angles both in sexagesimal value and in terms of circular value. Okay. So now let the two angles be alpha and beta. Let us write, let the two angles be alpha and beta. So these are the Greek letters. Okay, so these alpha and beta are the two Greek letters, right? So by question, sum of these two angles is equal to 135 degree. So you can write here, by question we can write sum of the two angles alpha plus beta is equal to what? It is 135 degree. Let us mark it as number 1. Okay, and the difference is pi by 12. Again by question, what can I write? That is again their difference, alpha minus beta is equal to pi by 12. Now this is given in terms of radian. So this is given in terms of radian. You have to convert into sexagesimal system. Therefore alpha minus beta is equal to pi means 180 degree divided by 12, isn't it? So or alpha minus beta is equal to, you can cancel it or you can divide it. 12 ones are 12, 18 minus 12 is 6, 60, 12 fives are 60, 15 degrees. So this is equation number 2. Now we have to find out both these two angles alpha and beta both in circular value or in terms of sexagesimal value. Okay, so let us solve it. So solving 1 and 2. So solving 1 and 2. Therefore it is alpha plus beta is equal to 135 degree and alpha minus beta is equal to, that is your 15 degree. Okay. So now in this case, let us add them. If you add, you don't have to change the sign here. Beta beta gets cancels. So it is alpha plus alpha. 2 alpha is equal to, you can add it. 5 plus 5, 10, 0, 1, 4 plus 1 is 5, 1. It is 150 degree, or alpha is equal to 150 degree divided by 2. So what is alpha is equal to 2 sevens are 14. 15 minus 14 is 1, 10. 10 divided by 2 is 5. So it is 75 degree. So we have got one of the angles in terms of sexagesimal value, that is 75 degree. So putting the value of alpha in 1 or 2, putting the value of alpha in, either you can put it in equation 1 or in equation 2. Let us put it in equation number 1. In 1, okay. So what is 1 here? Alpha plus beta is equal to 135 degree. Or what is alpha here? It is 75 degree plus beta is equal to 135 degree. Or what is beta is equal to? It is 135 degree minus 75 degree. Or what is the value for beta? 5 minus 5 is 0, 13 minus 7 is 6. That is your beta is equal to 60 degree. Is that clear now? So we have found out both the angles in sexagesimal value. Therefore, two angles in sexagesimal value is equal to, what are they? So one is 75 degree, and what is the other one? And the other one is 60 degree. And the other one is what? 60 degrees. So these are the answer for the first part. So we have calculated two angles in sexagesimal value, that is 75 degree and 60 degree. Now we have to convert these two angles in terms of circular value. So now let us convert into circular value. Circular value means in terms of pi radians. So let us convert 75 degree into pi radian. So you know that it should be multiplied by pi radian by 180. And 60 degree can also be converted into pi radian. That is, it is multiplied by pi by 180. Okay. So here you can cancel it by 5. 5 ones are 5, 5 5s are 25. 5 times 5 3s are 15, isn't it? 5 3s are 15. 18 minus 15, 3, 30. 5 6 are 30. Okay. Again, it can be cancelled by 3. This is 3 5s are 15. 3 1s are 3. 3 2s are 6. Okay. So here you can cancel it by 61s are 60. 63s are 180. So which is equal to, this is 5 pi radian by 12 and this is pi radian divided by 3. So we have got the two angles in terms of circular value, that is 5 pi radian by 12 and pi radian by 3. So therefore two values or two angles in circular value is equal to, what is it? It is 5 pi radian divided by 12 and what is the other one? It is pi radian divided by 3. So these are the answers. Is that clear? So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 7. The question number 7 is that, the question is given that if the ratio of three angles of a triangle is 2:3:4, then let us determine the circular value of the greatest angle. If the ratio of three angles of a triangle is 2:3:4, so you have to find out the circular value of the greatest angle of the triangle. You have to find out the circular measure of the greatest value of the greatest angle. You have to find out the circular measure of the greatest angle of the triangle. Okay. So what is given in the question? The ratio of three angles of a triangle is given as 2:3:4. So you have to find out the greatest angle. You have to find out the greatest angle of the triangle, but you have to find it in terms of circular measure. Okay. So here it is given that ratio of three angles of a triangle is equal to, it is given as 2:3:4. Okay, so in this case we can assume the three angles of a triangle in circular measure. We can assume the three angles of the triangle in circular measure if their ratios are given. So we can assume it as, if 2 is multiplied by a quantity, then these 3 and 4 should be multiplied by the same quantity. If 2 is multiplied by a quantity, then 3 and 4 should also be multiplied by the same quantity. Okay, this ratio means if you multiply these 2 by a quantity, then you should multiply these 3 and 4 by the same quantity. Okay, suppose this 2 is multiplied by x, these 3 and 4 should also be multiplied by x. So in that way we can assume the three angles of the triangle. So let us write here, let the three angles of the triangle in circular measure be 2x, 3x and 4x. So all these numbers are multiplied by the same quantity. That means we can assume the three angles of a triangle in circular measure as 2x, 3x and 4x. So these are the three angles of a triangle in circular measure. So what is their summation? Therefore 2x plus 3x plus 4x in terms of radian it is pi radian. Okay, so let us add them. 2x plus 3x plus 5x, 4 plus 3 7 plus 2 is 9, 9x is equal to pi radian, or what is the value for x here? It is pi radian divided by 9. So that is the value for x. So which is the greatest angle out here among these 2x, 3x and 4x? The greatest angle is 4x. So you have to find out the value for 4x. So therefore greatest angle in circular measure, is equal to, how much is it? It is 4x. It is 4x, which is equal to 4 into, what is the value for x? It is pi radian by 9. Pi c means pi radian divided by 9, which is equal to 4 pi radian divided by 9. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next problem. That is, actually this is a formula. The formula is that if the length of an arc of a circle whose radius is r is s, the length of an arc of a circle is s and the radius of the circle is r, and if the length of that r subtends an angle theta at the center of the circle, then prove that s is equal to r theta. Here theta is in terms of radians, or theta is in circular value. Okay, so in the question it is given that the length of an arc of a circle is only s, and what is the radius of the circle? It is r. And if that length of the arc s subtends an angle theta at the center of the circle, then the formula, or you have to prove that s is equal to r theta, where theta is in circular measure. Is that clear? So let us draw the figure out here. Let us draw a circle here. Suppose this is a circle. Suppose this is a circle. So the center of the circle is O, and suppose this is the radius of the circle. Suppose this is R. What is the radius of the circle? This is R. So let us take an arc of a circle that is xy, whose length is what? S. Let us take the length of the arc. Let us take the arc xy. Let us take the arc xy. Let us take this arc xy. Let us take this arc xy, whose length is S. And suppose this length of the arc xy suppose this arc xy subtend an angle theta at the center of the circle. Let us join OY, and it subtends an angle theta. It subtends an angle theta at the center of the circle. Is that clear? Now let us take here an arc XP. Let us take an arc XP here. Let us take an arc XP out here, whose length is equal to the radius of the circle. Suppose this length of XP is R. Okay, so let us take the arc XP here, whose length is equal to the radius of the circle. And by definition, you know that angle XOP is 1 radian. So here XP is equal to R. Here the arc XP, here arc XP is equal to R. That is the radius of the circle. Length of the arc XP is equal to radius of the circle. So you know that angle XOP is equal to 1 radian. Here angle XOP is equal to 1 radian. This is by definition. You know the definition of a radian, isn't it? 1 radian is an angle subtended at the center of the circle by an arc of the circle whose length is equal to the radius of the circle. I told you about it, isn't it, while doing this concept of measurement of angles in the beginning. Is that clear? So let us take here, let xy be the arc of the circle, whose length is S. Whose length is S. Okay, and what is the radius of the circle? Radius of the circle is equal to R. Therefore, the arc XY subtends an angle angle XOY is equal to theta at the center of the circle. Okay, therefore the arc XY, whose length is S, subtends an angle XOY is equal to theta at the center of the circle. Is that clear? That is the length, that is the arc XY whose length is S, subtends an angle XOY which is equal to theta at the center of the circle. Okay, and what is the radius of the circle? What is the radius of the circle? That is R. Okay, let the length of the arc XP be R, where R is equal to radius of the circle. Where R is equal to radius of the circle. Where R is equal to radius of the circle. Okay, let the length of the arc XP be R, where R is equal to radius of the circle. Okay, the arc XP whose length is equal to the radius of the circle subtends angle XOP at the center of the circle. at the center of the circle. Is that clear now? So here XP, length of arc XP, length of arc XP, what is the length of the arc XP is equal to R. Okay, so by definition, what is angle XOP? What is angle XOP is equal to 1 radian. Is that clear? So by definition, angle XOP is equal to 1 radian. You know that, isn't it? So what is 1 radian? 1 radian is an angle subtended at the center of the circle by an arc whose length is equal to the radius of the circle. Okay, so here angle XOP is equal to 1 radian because length of the arc XP is equal to radius of the circle. So angle XOP is equal to 1 radian. Okay, so now we know that in a circle the angle subtended at the center by different arcs is equal to the length of their arcs, is equal to the ratio of the length of their arcs. Okay, so again, in a circle we know that the ratio of the angle subtended at the center by different arcs is equal to the ratio of the length of their arcs. Is that clear? So let us write here, we know that in a circle the ratio of the angles subtended at the center, we know that in a circle the ratio of the angles subtended at the center by different arcs is equal to the ratio of the lengths of their arcs. So I think you have understood it. That is, we know that in a circle the ratio of the angles subtended at the center by different arcs is equal to the ratio of the lengths of their arcs. Is that clear? That means we can write here, therefore that is angle XOY. That is angle XOY divided by this angle XOY is subtended by the arc XY, isn't it? Divided by angle XOP. This angle XOP is subtended by the arc XP, which is equal to, you can write here, length of arc. So this angle XOY is subtended by the arc XY, length of the arc XY divided by angle XOP is equal to length of the arc XP, length of arc XP. Okay, so or what is angle XOY here? It is theta. Angle XOY is theta, isn't it? That is angle XOY is theta. What is angle XOP? What is angle XOP? It is 1 radian. This is your 1 radian. Is that clear? Is equal to, what is the length of the arc XY? What is the length of the arc XY? What is the length of the arc XY? XY be the arc of the circle whose length is S. That is S. Length of the arc XY is S. Divided by what is the length of the arc XP? This is equal to the radius of the circle, that is S. That is R. What is the length of the arc XP? It is R. Okay. So you can cross multiply it. Is that clear? So it is theta is equal to S upon R. So theta is equal to, this is 1 radian, so theta is equal to S upon R, or you can cross multiply it, S is equal to R theta, where theta is in radians, where theta is in what? In terms of radians. So we have proved it. So this is very, very important formula, that is S is equal to R theta. What is the S here? S is the length of an arc. S is the length of an arc which subtends an angle theta at the center of the circle whose radius is R. Okay, that is your S is equal to R theta. So this question is very, very important, and this formula is also very, very important. Okay, so you have to remember that S is equal to R theta. What is S? S is equal to length of an arc. What is theta? That length of the arc subtends an angle theta at the center of the circle. And what is R? R is the radius of the circle. Is that clear? So it is S is equal to R theta. So you have to remember this formula, S is equal to R theta. Okay, so you can copy it. Now we'll do question from the book. So now we'll do the next question, that is question number 8. The question is, the length of the radius of a circle is 28 centimeter. So in this case, in the question it is given that the length of the radius of the circle is 28 centimeter. Let us determine the circular value of the angle subtended by an arc of 5.5 centimeter length at the center of this circle. So now in the question it is given that there is a length of an arc. The length of the arc is given as 5.5 centimeter and it subtends an angle at the center. You have to find out that angle subtended at the center in terms of circular measure. Is that clear? So in the question it is given that the radius of the circle is 28 centimeter and there is an arc of length 5.5 centimeter and it subtends an angle at the center of the circle. So you have to find out that angle subtended by the arc of length 5.5 centimeter at the center in terms of circular measure. Is that clear? So now let's do this problem now. Here the length of the radius of the circle is 28 centimeter. What is the radius? R is equal to, this is 28 centimeter. Okay. Then what is the length of the arc? That is your value for S. S is equal to, that is 5.5 centimeter. Now we have to find out the angle at the center of the circle. That is the angle subtended at the center of the circle by the length of the arc 5.5 centimeter in length. Okay. So you have to get the value for theta in terms of circular value. Okay. So we know that S is equal to R theta, or theta is equal to S upon R, or theta is equal to, what is the value for S in this case? It is 5.5 divided by, what is the radius? It is 28. So you have to write it in terms of pi, in terms of pi radian, in terms of pi, isn't it? Pi, you know that pi is equal to 22 by 7, you know that, isn't it? So that is in terms of radian. So therefore theta is equal to 5.5 means 5.5. So 5.5 means after decimal point there is one figure. So you have to write, after, if there is one figure after decimal point, you should write 10 and you should write 110. That is, what is 5.5 in terms of fraction? It is 55 by 10 into, this is 28. Okay. This is 5 2s are 10, 5 11s are 55. That is, theta is equal to 11 by, this is your 56. But you should write it in terms of pi. Okay. So you know that pi is 22 by 7. Now it is in terms of radian. Pi means 22 by 7, isn't it? So theta is equal to 22 by 7. Let us write, let us multiply it by 2. If we multiply it by 2, it will be 22 divided by, now in this case 56 into 2. So if you multiply the numerator by 2, you should multiply the denominator also by 2, so that we can make here 22 by 7. And you know that 22 by 7 is pi radian, isn't it? So, or now this is theta is equal to 22 by 11 2s are 22. 56 means 7 into 8 into 2, right? 56 means 7 into 8 is 56. 7 8s are 56, okay? Or theta is equal to 22 by 7 means pi, divided by 22 by 7 means pi, isn't it? You know that. Pi is equal to, this is 22 by 7. So it is 22 by 7 means pi. What is 8 2s are? 8 2s are 16. So what is the circular value of the angle? Subtended at the center of the circle, it is pi by 16. That is your answer. Therefore, circular value of the angle, subtended at the center of the circle. Subtended at the center of the circle, is equal to, what is the answer? It is pi by 16. That is in terms of circular value. Is that clear? So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 9. Question number 9 is the ratio of two angles subtended by two arcs of unequal lengths at the center is 5:2. And if the sexagesimal value of the second angle is 30 degree, then let us determine the sexagesimal value and the circular value of the first angle. So the question says that there is a circle, and there are two arcs of a circle given, and these two arcs of a circle subtend angles at the center of the circle, and the ratio of these two angles subtended at the center is 5:2. Okay, so now if the sexagesimal value of the second angle is given as 30 degree, the sexagesimal value of the second angle is given as 30 degree. Now you have to find out the first angle. You have to find out the first angle both in sexagesimal value and in the circular value. Is that clear? So again I am explaining the question. Just try to understand it. There is a circle, and the two arcs of unequal lengths of the circle are given, and these two arcs subtend angle at the center of the circle, and the ratio of these angles subtended at the center of the circle is given as 5:2. Okay, so now what is given again here? If the sexagesimal value of the second angle is 30 degree, so you have to find out the first angle both in sexagesimal value and in the circular value. So I think you have understood the question. So let us do this question now. So now in the question it is given that ratio of angles first arc is to second arc. Okay, so first arc and second arc will subtend an angle at the center of the circle, and their ratio is given. It is given as 5:2. It is given as 5:2. And now what is the sexagesimal value of the second angle? Sexagesimal value of the second angle, it is given as 30 degree. Okay, sexagesimal value of the second angle is given as 30 degree. Okay, so let us write it in terms of radian. Okay, so 30 into pi by 180. 31s are 30, 36 are 180, which is equal to, this is your pi by 6. Okay. Sexagesimal value of the second angle is 30 degree. So let us write it in terms of radian. Don't write it here. So sexagesimal value of the second angle is equal to 30 degree. Therefore, circular value. Let us find out circular value. Circular value of the second angle. Circular value of the second angle is equal to 30 is multiplied by pi by 180. Okay. 31s are 30, 36 are 180, which is equal to pi by 6. What is the circular value of the second angle? It is pi by 6. Now, therefore, angle subtended by first arc, angle subtended by first arc divided by angle subtended by second arc, angle subtended by second arc, it is given in the question, which is equal to, this is 5 upon 2, which is equal to 5 upon 2. Or now we have to find out the angle subtended by the first arc, both in circular measure and in terms of sexagesimal value. So let us assume it as theta divided by, what is the angle subtended by the second arc? Angle subtended by the second arc in terms of radian is pi by 6. Pi by 6, which is equal to 5 by 2. So let us do cross multiplication here. What is theta is equal to? Theta is equal to 5 by 2 into what? Pi by 6. It is pi by 6. Now it is cross multiplied. Okay. So theta is equal to pi by 6 multiplied by 5 by 2. Or what is theta now in this case? It is 5 pi divided by 12. That is, this is the first angle in terms of circular value. Therefore, circular value of the first angle, circular value of the first angle, circular value of the first angle is equal to, what is the answer? It is 5 pi by 12. You may write 5 pi c by 12 also. That is in terms of radian. Or you may just write 5 pi by 12 also. So let us convert into sexagesimal value. Therefore, sexagesimal value of the first angle is equal to, how can you convert into sexagesimal value? You know that pi is 180 degree, isn't it? In terms of degree, pi is 180 degree. Pi is 180 degree in terms of sexagesimal value. Okay. So 12 ones are 12, 12 ones are 12, 12 fives are 60, 15 degree, 15 fives are, it is your 75 degree. So this is the final answer. So I think you have understood it. Okay. So now you can copy it. So this one is for today. So today we did 5 problems. You revise all these 5 problems at home, and also you do the previous problems also in this chapter, concept of measurement of angles. If you don't understand anything, you can ask me, you can call me, or you can write down the comments. Okay. So in the next online class, we'll do more problems on this concept of measurement of angles. So this much is for today. So you can copy it.